Okay, hello students. Mr. Nelson here. So today we're starting our new unit for Pre-Cal 11, trigonometry. But in grade 11 here, things change a little bit because we are going to start working in our Cartesian coordinate plane. So if you remember Cartesian coordinates, there's an x-axis and a y-axis, and we have positive x to the right and negative x to the left of our y-axis, and positive y to the north of our x-axis, and negative y to the south. This is our Cartesian coordinate system, and we are introducing something called a unit circle. Okay? And why do we call it a unit circle? And a unit circle looks like, it's essentially a circle whose middle sits on the origin. Okay, so my circle does not look very good. So let me try and make that just a little bit more to scale. It's as good as I'm gonna get, I'm sorry. And why do we call it a unit circle? Because the radius of this circle is always 1. R is equal to 1. That makes it a unit, so our unit is 1. So no matter where we draw a radius on this circle from the middle, from our origin, the radius will always be 1. Okay, so it's a unit, 1, a circle. Okay? So what is important about this? Well, because we're dealing with trigonometry, we're going to be dealing with angles. So we need to introduce first a couple new concepts as well. We need to know what an angle in standard position is. What is an angle in standard position? Well, an angle in standard position is any angle that is formed with a radius, or we call it a terminal arm. We also call this a terminal arm. So that's our terminal arm. So it's the angle, theta, that is made with respect to our positive x-axis, which is our initial arm. So our angle starts from here, from this axis. It's always from this positive x-axis that the angle starts from. And our angle in standard position moves counterclockwise and forms an angle with whatever our radius or our terminal arm is. Okay? So in this case, our angle in standard position, if I was to use forget the protractor, I put that there, and I would figure out that my angle starting from 0 is about 55 degrees. So this is about 55 degrees. Okay? That is my angle in standard position. So my angle in standard position is the angle that's formed between the terminal arm and the initial arm. And the initial arm always lies on my positive x-axis, okay? So that is the angle in standard position. And so, say for example, I drew a terminal arm that was over here, okay? So now, my angle in standard position for this guy will be the angle that starts here and goes all the way to that arm. So in this case, if I was to measure with my protractor that angle, well, up here is 90 degrees, right? Because each quadrant here forms a 90-degree angle. So this is positive 90 degrees with respect to the initial arm here, and this would be over here 180 degrees. Okay? So my angle in standard position for this guy, if I measured, is about 135 degrees, okay? So this angle, this whole angle is 90, 135 degrees. Now I know that if I was to keep going and I would land here, well, if I came all the way down here, that would be 180 degrees. So I can actually figure out another angle, what we're going to start calling our reference angle. Our reference angle, theta r, is whatever angle is made from our terminal arm being the arm that makes the angle, to the x-axis, the closest point on the x-axis. So the closest x-axis is this direction, not this direction. Because if I go this direction, I go 135. If I go this direction, I'm only going 45 degrees. So my reference angle in this case is 45 degrees. This comes in handy in the next part of the unit when we start working with our actual trig ratios. But for now, you just need to know that an angle in standard position starts at the initial arm and ends at the terminal arm. And the angle is made moving in a clockwise direction. We can also have, so for every terminal arm here, we have a second angle. It's called our coterminal. Our coterminal angle. Co means same or shared. Terminal means this. So we know that moving in this direction, we're moving in positive angles, right? Our angles are increasing. They go from 0 to 90 to positive 180. If we go down here, we add another 90, so this would be positive 270. And all the way back, this is positive 360. We've gone 360 degrees. A circle all the way around is 360 degrees. Halfway around a circle is 180. 360, like that. 180 is just half. Okay, so I'm facing this way and I just go half. That's 180. So moving counterclockwise is positive, but we also can count angles negatively. So if I'm moving in this direction, my angles count negatively. So we start at 0. This, instead of positive 270, this would be negative 90. This would also be negative 180 degrees. This would be negative 270. And then this would be negative 360. So for every terminal arm, I have two angles. I have one that's going to be positive because I'm moving counterclockwise, but it's also going to have another angle, this guy, which is going to be my negative angle. And so in this case, it would be 90, negative 180, and then negative 180 plus 45 is negative 225. So this other angle is negative 225. So the coterminal angle for this angle in standard position is negative 225. So each terminal arm has also a coterminal arm that forms its own negative angle because we go clockwise. So clockwise is negative, counterclockwise is positive. So we have a unit circle, we have angles in standard position, the angles that are made moving positively from our x-axis, our positive x-axis, and then we have coterminal angles that are formed moving clockwise. And then our reference angle for any arm, say for example here, this was another terminal arm, our reference angle is the angle that's made between the arm and the closest x-axis. So in this case, the closest x-axis is not over here, it's over here. So my reference for this angle, my reference angle for this arm would be the angle from this point to there. So say for example it was 60 degrees. And if that's the case that my reference angle is 60 degrees, then for this guy, I can figure out the two coterminal angles. So one will be starting from here and moving negatively to this line. So it would be negative 90, and then I know that this all has to be 90 degrees, but this is 60. So it would be negative 90 plus 90 minus 60 is 30. So negative 90 plus negative 30 This would be negative 120 degrees. That's one terminal. And then the other one would be going positive. So it'd start up here and we move the opposite direction. So we keep going until we hit here. So this would be 90, 180, 180 plus 60 is 240 degrees. So those are the two coterminal angles for this terminal arm. So the other is a reference angle. Reference angle is my theta r, and it's the angle to closest x-axis. And this comes in handy in the next part